Welcome to today's class. Tan A plus secant A is equal to, prove that tan A plus cot A is equal to secant A into cosecant A. Let's take the NHS and write the tan A as sin A by cos A and cos A as cot A as cos A by sin A. Cos A into sin A becomes the LCM. And cross multiplication, sin squared A plus cos squared A. Sin squared A plus cos squared A is the identity 1. So 1 divided by cos A into sin A. 1 by cos A is secant A and 1 by sin A is cosecant A. That's our RHS. Let me go to the second question. Cos to the power 4a minus sin to the power 4a two cos squared a minus 1. Here I am using a square minus b square for the left hand side, which is a plus b into a minus b becomes cos squared a minus sin squared a bracket cos squared a plus sin squared a. As we have cos square a plus sin square a is 1 and cos square a minus sin square a remain as it is. Now we write this sin square a as 1 minus cos square a. So cos square a minus 1 minus cos square a. So cos square a minus 1 minus of minus becomes plus cos square a, which is 2 cos square a minus 1. We got the answer. Moving on to the next question. sin A over 1 plus cos A. One plus cos A over sin A is equal to 2 cosecant A. We take the LHS, we add the fractions, it goes cross multiplication, sin A into sin A goes sin square A, 1 plus cos A into 1 plus cos A whole square divided by 1 plus cos A multiplied with sin A. Sin A multiplied with 1 plus cos A. So now open this bracket, 1 plus cos A as whole square, sin square A plus B whole square is A square, which is 1 square, plus 2AB will become 2 cos A, plus B square is cos square A. Denominator is sin A, 1 plus cos A. As you can see, sin square A plus cos square A in the numerator, which is equal to 1, and 1 square is 1. So 1 plus 2 cos A over sin A into 1 plus cos A. 1 plus 1, 2. I will take 2 common factor. 1 plus cos A over sin A bracket 1 plus cos A. I can cancel the bracket 1 plus cos A, 1 plus cos A. So the remaining answer is 2 by sin A, which means 2 cosecant A. We got the required RHS, hence proved. Let me take the next question. One plus cot A the whole square plus 1 minus cot A the whole square is equal to 2 cosecant squared. Taking the left hand side, 1 plus cot A whole square, A plus B whole square is A square plus B square plus 2AB, 2 cot A. Similarly for the second bracket, again A plus B the whole square, 1 square is 1, B square is cot square A, and minus 2 cot A. Plus 2 cot A minus 2 cot A cancels. The remaining answer is 1 plus 1, 2, cot square A plus cot square A, 2 cot square A. 2 common factor, 1 plus cot square A. And 1 plus cot square A is identity. cosecant square A. 2 into cosecant square A, which is the required right hand side. LHS equal to RHS, hence proved. I'll take the next question. Tan to the power 4a plus tan square a is equal to secant to the power 4a minus secant square a. Let us take the left hand side. I take tan square a common factor between the two terms. Tan square a common. Tan square a plus 1. Now, tan square a plus 1 or 1 plus tan square a is the identity secant square a. So we get tan square a multiplied with secant square a. Now, the tan square a is secant square a minus 1. So I can use the identity secant square a minus 1 multiplied with secant square a. Now I open the bracket by multiplication. It is secant to the power 4a minus secant square a. I got the required RHS. I hope you all noted this. Let's move on to the next question, which is basically you should be thorough with all the three identities, which is sin square a plus cos square a is equal to 1, which can be reframed as sin square a is equal to 1 minus cos square a, or cos square a is equal to 1 minus sin square a. Similarly, we have two more identities. This is the first principle. Second one is secant square a minus tan square a is equal to 1, which can be written as secant square a is equal to 1 plus tan square a. Similarly, secant square a minus 1 is tan square a. And we have the next identity, which is based on cosecant and cot. Cosecant square a minus cot square a is equal to 1, or cosecant square a is 1 plus cot square a, or cot square a is cosecant square a minus 1. These are the identities, the three major identities, which can be simplified to the below mentioned form. With that introduction, again I will continue with the next question. One plus cos a over 1 minus cos a. as cosecant A plus cot A whole square. Taking our left hand side in this, one minus cos A, 1 plus cos A. I multiply the numerator and denominator with the conjugate of base, that is 1 minus cos A. Here I use 1 plus cos A, 1 plus cos A. So 1 plus cos A by 1 plus cos A is nothing but 1. Multiplying 1 by 1 will not change any value. So now after this I will multiply along the denominator and along the numerator. So 1 minus cos A into 1 plus cos A gives me 1 minus cos square A in the denominator and 1 plus cos A whole square in the numerator. One minus cos square A, I get sin square A, and 1 plus cos A whole square I remain as it is. Now let me use this sin square inside the bracket as sin A and 1 plus cos A whole to the power 2. Now I distribute that sin A denominator to both the numerators. 1 by sin A plus cos A by sin A, the whole square. 1 by sin A is, we know, cosecant A, and cos A by sin A is cot A whole square. We got the required right hand side, hence proved. So here I finished the class. I'll be continuing an online class daily around 9 p.m. to 9:30 p.m. So I'm continuing the trigonometric series in this class. If possible, you can join the live class, or else you can go through the video later. Subscribe to my channel for further information.